Okay, okay, brilliant people. It's Mr. Ryan. I am sick right now. I am at home. I am not feeling my greatest, but I know that education stops for no man. So I do believe in giving you your education even when I'm homesick. So today we are going to be working on a very, very short lesson because you will be working on your reviews for the remainder of class. Today we're talking about 7.6. It is only going to be 6 questions today. We're going to talk about 2 variations of solving exponential equations. As we should know from all of the talking that we've done, exponentials and logarithms are opposite of one another. They are inverses. They are inverses. So we're going to swap our domain and range from our logarithms, and they are going to fit our exponentials. So for my domain, I have negative infinity, comma, positive infinity. So here, I know that my x values for domain go on forever in both directions, while my exponential range goes from 0 to infinity. Here, 0 is excluded, meaning I have an asymptote at a number, an asymptote. When you are graphing them today, make sure that you are remembering your asymptotes. When it comes to our range, these are our y values. So if range is my y values, and my y values have to be above 0 here, my range must be above 0, so y must be above 0. If that is true, then we are working with our exponentials. We're not going to have to actually be testing them like we've been doing for our logs, but it's important to note that our answer to an exponential cannot be a negative, for example. It cannot be a negative because here, this is where y is greater than 0. It's a positive answer. So when we see a negative is equal to our exponential, we should have a little bit of an alert signal go off. I'm not saying that it won't work to work with. I'm just saying that there's probably something we have to do to our equation to make it work. Otherwise, equal to a negative, probably not a way to go. Today, if we're talking about our type 1, our first 3 questions are about base 10 or E, meaning they are calculator ready, ready for calc. Ready calc. And we're going to do the same thing that we do with our logarithms. We're going to get our exponential by itself, meaning if we have any addition, any subtraction, any multiplication, any division, we got to undo it. We got to get rid of it. So our exponential is by itself. For our first one, we see 10 to the x power. That is by itself. I don't see any addition. I don't see anything multiplying to it. I don't see anything subtracting or a fraction that's dividing. So we're going to go straight into using our logarithms. Do we see a logarithm here when it comes to our first question? No, we see an exponential. So we're going to have to change our notation from exponential to log. To do that, I have made an arrow going in the wrong direction. Sorry. Go ahead and change that. We're going to go from our exponential to our logarithm. We're going to take our base and we're going to put it at the bottom of our log. So we're going to be putting a log here because we're changing from exponential to logarithm. And our base here is our 10. So I have log base 10. And whatever our value was equal to from our exponential is now going to be with our log. So I get log base 10 of 41 is equal to our exponent, which is x. Again, our base matches. So the first number, it becomes our base. And then y goes inside, and it's equal to our exponent. So because it has a base of 10, it's ready for the calculator. So please grab your calculator. I didn't bring one of my calculators from class, so you're going to have to see my calculator from high school and college and now. Log base 10 is ready for your calculator. You're just going to press log. It is going to be on the left side of your calculator. And we're going to plug in our 41. Remember, our log is already defaulted to a base of 10, so we won't have to do anything to it. Get into a habit of closing your parentheses, and it's equal to 1.612, and that 7 is going to change and round my 2 to a 3, because we are going to be rounding to the nearest thousands place. It goes tens, hundredths, thousands place. So my answer here, and maybe it's starting to get dark. Should I put my light on? Is that going to be okay? Yeah, I think so. Okay. I have 1.61. My 7 is rounding my 2 to a 3. And it's approximately, so we're going to use this curly equal sign, equal to x. Approximately equal to x. And that's all we're going to do. For this next one, we see this -1. We're subtracting 1. We got to get rid of it so I can get my exponential by itself. We're going to add 1 on both sides. I get 10 to the v plus 9 is equal to 48. If you want to race me a little, go ahead and make your log. I'll go a little slower. Go ahead and make your log. We get log. Because we're changing our exponential to a log, we just, by default, start with a log. What's our base? 10. What's our value inside my log? 48. And this is equal to our v plus our 9. So we're going to plug our log base 48 into our calculator. And parentheses, get in the habit. I get 1.681. This 2 does not round my 1 up, so it stays as a 1. If you want, right away, you can go ahead and subtract 9 from your answer and see what you get. But I will say that it's easier for me to give you guys partial credit on your test if you show me what you got on your calculator beforehand, because then I can see where something went wrong. Ooh, I was already ready. There you go. So I'm going to subtract 9 on both sides to get my v by itself. I get negative 7.31. This 7 is going to change my 8 to a 9. So negative 7.319 is approximately v. Okay. And now we're looking at that interesting one where it's equal to that negative. A reminder that our y, so our answer is usually what our y value is. So our answer should usually be a positive number because it's greater than 0. However, is our exponential by itself right now? Is there anything adding, subtracting, multiplying, or dividing my e? Let's look at this negative 7. Is there an addition sign between my 7 and my e? No, there is not, which means there's multiplication happening in between there. So we're going to have to divide negative 7 on both sides. Don't be afraid of your fractions because we're working with decimals today. So my negative 7s cancel. I get e to the x minus 5 is equal to negative and negative make a positive. Very good. 59 over 7. Now it's ready to change to my log version. What's my base here? My base is e. So do we remember what log base e is? Log base of e. We should be going, oh my god, it's ln. And if that's not what's going down in your mind, I would like it to. Go ahead and think about that. How log base e is our natural log of ln. So we got our ln. Same thing as log. We're not changing too much. If you want to put an e just to make yourself happy, you definitely can. It doesn't change anything though. And then I get my 59 over 7 with my ln. And this is equal to my exponent, my x minus 5. Do I still have an exponent in my answer? No, I do not. I have a little base, but I do not have an exponent in my answer. So we're going to plug this into our calculator. ln should be like right next to your log button. Parentheses 59 divided by 7 and parentheses. I get 2.132 because the 6 is going to round my 1 to a 2 is equal to x minus 5. We're going to add 5 on both sides. 5 plus 2 gives me 7, so 7.132 is approximately x. If you want to add 5 for good measure on your own, you definitely can. You'll see that you get the same answer. That's it for the first page. When you are ready, go ahead and meet me on the back. Alright, you guys, we are almost done. We're going to be talking about change of base formula because now we're not going to be working with those calculator-ready questions. We're going to have other bases we are working with. If you have a highlighter, go ahead and highlight this part because we are going to have to change your log into a calculator-friendly version for yours. Yours isn't as fancy as mine because yours doesn't cost $100 or $120, whatever it may be now. What's going to happen is we're going to take our base value and put it on the bottom with a log. And then my value, so my x here, is going to go on top of the log. So we can divide this very easily in our calculator. So first we're going to make sure our exponential is by itself. 9 to the x power, yep, by itself. And we're going to take log of both sides. What I really mean by that is we're going to change to log form. Change to log. I think that this might be old instructions. I apologize. Or maybe I just wrote it wrong when I was making this. Whatever it may be, I'm human. So here we have our exponential. We're changing it to log. So the first thing we're going to do, now that we know that our exponential is by itself, our base is our first number, so it's 9. Then our second number is 57. And it's equal to x. Unlike before, it's not ready for the calculator just yet. We have to create the fraction version. We call that my COBF, my change of base formula. So I get log on top, log on the bottom. And my numbers are my big 57 goes on the top one, and my base goes on the bottom. I'm putting it in parentheses on purpose because on your calculator, you better be closing those parentheses. So here I get log parentheses 57 and parentheses, oh, I put too many parentheses, log 57 and parentheses divided by log of 9 and parentheses. You should get 1.840 is equal to x. I want 3 decimal places, so yes, you will be adding that 0. On your review, it might even ask you for 4 decimal places. Please make sure you're reading your instructions. Okay, go ahead and without me, maybe pause me, and change this to your log form. Okay, I hope you guys are ready, because there's your log. You got your log base of 2 of 29 is equal to 4n. Again, now this is ready for our change of base formula, COBF. We're going to change it into a fraction now. I get log of 29, and parentheses is divided by log base 2, so log of 2. And this is equal to our 4n. A little reminder that this 4 still needs to go somewhere after you're done with your calculations. So I get log of 29 divided by log of 2, and parentheses, I get 4.857. This 9 changes my 7 to an 8, is equal to 4n. I'm going to divide by 4 on both sides. I get 1.21. Ooh, this one's interesting, because you might want to ignore that 9 and try to look at this 4, this fourth place 4, and say, oh, well, this 4 is not going to round up because that's a 4. However, this 9, let's look at this. I got 1.21449. This 9 changes this 4 to a 5. So I get this now. So now that this is a 5, what happens to this 4? It also changes to a 5, so this is approximately n. 1.215 is approximately n. Right about now, I would ask you to talk to your neighbors to make sure you guys can round, so maybe it would be a good time. Go ahead and do this last one as a you try. I will give you guys a second to pause this and do it yourself. See what happens. Make sure you move that 7 to get my exponential by itself. Alright, ready. Isolate by adding 7 on both sides. Now you have it equal to 75. Then you're going to convert to log. So you have log base 1175 is equal to 8k. And then you can make it calculator ready by making it a fraction. And when you plug it in, you should get this answer. I hope that you guys feel good about this. Good luck on your test when I see you guys next. And if you have any questions, send me an email. You guys got this. And let me know if you need anything. Have a great day. Bye-bye.